Okay, to help you get ready for your test next class, I'm going to go over on your review guide just one of every type of the problems to make sure you're ready to go. Okay, on these first 7 problems, you're basically doing the exact same thing. On all 7, you should start by factoring everything you can and then crossing out the things that do match in your problem. The only thing that's different on ones like 6 and 7 right here, because it's division, the first thing you will do is flip this second fraction so that you can turn it into multiplication. So do make sure to take that into account when you're working on those ones. I'm going to go ahead and do number 5 to give you some practice there. On number 5, the first thing that I want to do is start to factor. I can go ahead and start by just GCF factoring because I see there's a lot of that here. In the numerator, I can pull out a 2, and it will be 25 minus w squared. In the denominator, I can pull out a 3, and it'll be w squared plus 3w minus 10. In the second numerator, I can't pull out anything, so I'm just going to rewrite it for now. Again, you can go straight away to factoring that. It's whatever works best for you. And then in the denominator, I can pull out a 6. I can still do more factoring for most of these, so I'll go ahead and do that. In this numerator, on the first one, that is a difference of squares, so I'm going to pull out, or I'm going to rewrite that using difference of squares, so 5 minus w, 5 plus w. In the denominator, that is a trinomial that you're going to need to factor, so we are multiplying to negative 10 and adding to 3. Go ahead and actually do that, but for your final answer, you should get w plus 5, w minus 2. And if not, make sure you come see me so we can work on your factoring. For this numerator, again, we're going to factor it like a trinomial, so we're multiplying to negative 14 and adding to 5. Again, go ahead and factor that. What you should get is x plus 7, or sorry, w plus 7, and w minus 2. This denominator then cannot factor any more. Then we're going to go ahead and cross things out. So anything that matches can simplify. W plus 5 and 5 plus w are the same thing, so my signs are the same, so that can cross out. The w minus 2's cross out. The problem comes in with this 5 minus w and w minus 5. They are not exactly the same because my signs are flip-flopped. In class, what we talked about was that you could pull out a negative in one of the 2 spots, which changes both your signs, and then those will cross out. If I start to simplify this, this is negative 2 times w plus 7 over 6, which then these can simplify and give me negative times w plus 7 over 3. The 2 and 6 simplified. For your excluded values, remember you take your denominators before you simplified and set those equal to 0. So from w plus 5, I get that w cannot be negative 5. From the w minus 2, I get that w can't be 2. From the 6, there's no x there, so there's no excluded value, but from the w minus 5, I get a 5. So that is my final answer on that one. Okay, on 8 through, let's see, on 8 through 14, you are all going to add and subtract on those. So what you want to make sure with all of those is that you're getting a common denominator first. On number 8, you already have a common denominator, so you're just going to go ahead and subtract. Do remember to distribute that negative to both the x and the negative 20. But on 9 through 14, you do not have a common denominator, so you're going to have to find that first. So I'm going to talk through some of those common denominators because I know that's what some of us struggle with. On number 10, to get a common denominator, you're going to factor your denominator that you can. So for example, this one will factor to be m minus 9 times m minus 1. On the first one. What that does for me is, since the m minus 1 is included in both, my LCD can be m minus 9 times m minus 1. So you are going to multiply the second fraction by m minus 9. On 11, that's a difference of squares, and then you will also have an overlapping factor. On number 12, the 8 and the 24, you want to find a common number that both 8 and 24 go into, which would be 24. So my LCD will be 24a. So you'll multiply the first fraction by 3 and the second fraction by a. On number 13, neither of those have a common factor, so my LCD is all of both. So you're going to multiply the first fraction by h plus 5. You're going to multiply the second fraction by h plus 2 on top and bottom. On number 14, make sure you factor the x squared minus 4x plus 3. And then you're going to need to multiply just the two first fractions by a number to get your common denominator. Let's see, if I go ahead and finish, I'll do number 9 for us here. When I factor this second one, it will be 3 times k plus 5, which means my LCD is 3 times k plus 5. So I'm going to multiply the first fraction by k plus 5 on top and bottom so that the denominators will match. So it will be 16k plus 80 over 3 times k plus 5 minus 4k plus 56 over 3 times k plus 5. You do not need to factor the numerators until after you've combined them together. So then I'm going to do 16 minus 4 is 12k. 80 minus 56 is going to give you 24. Then I can factor out from that a 12. So it'll be k plus 2 over 3 times k plus 5. The 12 and 3 will simplify to give you a 4, which gives you your final answer. So it'll be 4 times k plus 2 over k plus 5. Your excluded values here would be negative 5 from setting this k plus 5 equal to 0. Okay, going to your topic 3 on here, which was your complex fractions. You started out very similarly. You're going to find me your LCD between the fractions that the little denominators that you have. So not your big fractions, but your little ones. So I'm specifically looking at I'm looking at this denominator, the m squared plus 4m plus 14m plus 45, and the m squared plus 7m minus 18. Or in the second one, you're looking at the 9. I don't know why it won't write. I apologize. The 9, the 3, and the 2. There we go. On number 17, you're looking at the 2, the b, and the b, because this one's over 1. On number 18, you're looking at all 4 denominators. So you want to find your LCD first. So for example, on number 17, your LCD would be 2b. Because you have a fraction within a fraction here, we're going to really just think about the operation as multiplying the top and bottom of the big fraction. And what that's going to do is cancel out our little fraction. So I'm going to write times 2b on every single term that I have here. When I do that, the 2's on this first one will cancel, so I have b times b is b squared. On this second one, the b's cancel, so I will do 32 times 2, which is minus 64. On the bottom, nothing cancels with this first one, so it will just be 2b. And then on the second one, the b's cancel, so 8 times 2 is 16. Then you want to go ahead and factor, so that numerator is a perfect difference of squares. The denominator, I can pull out a 2. Our b plus 8's cancel, and your answer is b minus 8 over 2. Okay, just to give you a hint on number 18, because that one is kind of tricky, you're going to factor this denominator. And then my LCD, you need the 3, because it's in the 2 denominators on the bottom. You need an x for this one, the 4 over x. And you also need the x plus 1. So your LCD is going to be all of that. On number 15, again, try to factor those 2 denominators first. Okay, on your application problems, start by thinking about what your formulas are. So this one's talking about area and wanting to find the width given the length. I know that area is length times width. if I want to solve that for width, I would divide out the length, and that would give me just my width. Well, if you look, they gave you the area, so we can plug that in. They gave you the length, you can plug that in. This is going to look like one of your complex fraction problems. So you're going to set it up as your numerator is the n minus 3 over n plus 7 over 2. Then your big fraction line over 3 over 4n minus 1 over 2n squared. And then you're going to do this one exactly like the last four. On number 20, volume of a prism is length times width times height. So you're going to go ahead and plug in all three fractions to this formula and solve this like your multiplication. So factor everything, simplify anything that matches. On 21, it's perimeter, so that means you're going to add everything up. So you're going to add up all three sides, get a common denominator, and do them just like your regular addition problems. Do make sure that you know some of these basic geometry formulas. So area of a rectangle, a square, and a triangle, volume of a prism, perimeter of anything, whatever you may need, because one will show up on your test. On solving equations, if you have a fraction equals a fraction, remember that you are allowed to just cross multiply this. So I would do 3 times a equals a minus 8 times a plus 5. You want to FOIL this out and then set it equal to 0 before you can actually solve it. So make sure to get that all the way out there. On ones like 23 through the rest of the solving equations problems, so 24 and 25 as well, you cannot just cross multiply because I did not give you a fraction equals a fraction. So what we talked about in class was clearing those fractions so that you could solve it like normal. The way that we clear our fractions is by multiplying by your LCD. So as you've probably noticed, that LCD is super important in 3 of these days. To find the LCD, I need to factor this one denominator right here that is factorable. To make sure you check me, but it should be p minus 6 times p minus 1, but again, make sure you agree with that. For your LCD then, I need the 3 from this fraction over here. I also need the p minus 6 and the p minus 1 from the left side. Then what we're going to do is write that next to all of them. I'm multiplying both sides of my equation by my LCD, because since it's an equation, you're allowed to do that. And it is going to clear all of my fractions for me. When I do this, on this first one, the whole denominator cancels, and it's just 3 times p squared plus p plus 8. The p minus 1's cancel here, so it'll be plus 2 times 3 is 6 times p minus 6. And over here, just the 3's cancel, so it'll be equals 2 times, I'm just going to shorthand this a little bit, p minus 6 times p minus 1, I know is p squared minus 7p plus 6, but you can FOIL that out again to make sure. Then I'm going to do this multiplication, so it's 3p squared plus 3p plus 24 plus 6p minus 36 equals 2p squared minus 7p plus, or 14p, sorry, plus 12. You want to get everything on the same side of the equation since this is a quadratic. When you do that and combine all your like terms, you should get p squared plus 23p minus 24 is equal to 0. And then this you are going to factor. So I'm multiplying to negative 24 and adding to 23. Make sure you can do this factoring, but you should get p plus 24 times p minus 1. When you set those equal to 0, you get negative 24 and positive 1. At this point, it is extremely important to check your excluded values. Go back to your LCD, set those equal to 0. So p minus 6 tells me that p can't be 6. P minus 1 tells me it can't be 1. And I got an answer of 1, which means I'm going to cross it out down here. And my only answer is negative 24. So make sure you're checking for your excluded values when you solve these problems. The last 2 days were over graphing. And much of it, the process was the same of finding your points and plugging it in and your shapes. What's different is how you find your vertical asymptote, your horizontal asymptote, and your holes. On day 1, you were given it in our more basic reciprocal function form, and your asymptotes were easier to find because they came from your equation itself. So this denominator, because that's what my x can't be, gives me my excluded values. and thus your vertical asymptote. So x equals -4 is your vertical asymptote. Your horizontal asymptote came from the number up back, so it was at y equals -7. When we did these, we always centered on our vertical asymptote, so -4, and I put a dash next to it, goes in the middle. Then you plug in 2 to the left, oops, -5 and -6, and 2 to the right, -3, -2. The answer key does have these graphs as well as the charts, so make sure you're looking at those. When you're thinking about domain and range, remember that your domain is everything x can be, so you're looking for really what x cannot be. What I know x can't be is this -4, so my domain is everything but -4, so -infinity to -4, and -4 to infinity. Range is the same idea, but with your y's, so the only thing y can't be is -7, so my range is -infinity to -7 and -7 to infinity. There are no holes here because I didn't simplify anything out. Your day 1 did not have any holes. Number 27 is going to work very, very similarly, so make sure you use that first one to help check it. Day 2 of graphing was our slightly trickier day with more rules, and so I'll go over some of these as well. To find your vertical asymptote, you are still doing the same thing of looking at what x cannot be, but sometimes you're going to have to factor to simplify your problem first. On number 28, we're not going to simplify it at all because you can't factor it. However, on 29, you can factor both the top and the bottom and simplify it out and get a more simplified equation. You can do the same thing on number 30, so 30 you can also factor. But your vertical asymptote, remember, comes from your simplified one. On my first problem, I couldn't factor it, and that's okay, so I just set my denominator equal to 0, and that still gives me my vertical asymptote of -2. On 29, you look at your simplified one. I would technically do 2 equals 0. That doesn't have an x value, so it tells me that I have no vertical asymptotes. On your horizontal asymptotes, that's where we have 3 different cases, and you have to figure out the case that applies in your problem. On this one, the degree of the top, so your biggest exponent, is equal to the degree of the bottom, which tells me in our notes we numbered that case 3, and you do your leading coefficient of the top, which is a 1, over the leading coefficient of the bottom, which is also a 1. So that tells me that my horizontal asymptote is at y equals 1. On number 29, it is a different case. It is where the top is bigger than the bottom. And that one tells you that you have no horizontal asymptote, again, because the degree of the top is a 2, degree of the bottom is a 1, so I have none. On the other case, your third case is where your bottom is bigger than your top. I believe number 31 looks like that if we go look. Yes, number 31, your denominator has a larger exponent than your numerator. And so that is the other case, I believe it was case 2 in your notes, where you do y equals 0 for your horizontal asymptote. So make sure you do know all 3 cases because they will all 3 show up. If we go back to these 2 to talking about them. So that's how you find your vertical and your horizontal asymptotes. For your holes, it is whatever you simplify out of your problem. So on number 28, we had no holes because we did not simplify anything out of our problem, and that is perfectly fine. Don't know why it's not writing again. You will have no holes on 28. On 29, your hole is from that -6 that I simplified out. So x plus 6 equals 0. Your hole is at -6. There we go. Now it's writing. To get the y coordinate, you would plug it into your simplified answer. So I would do -6 over 2, so -3. When you have that, do make sure you actually count over and plot an open circle on that point. Once you've figured out your asymptotes and your holes, you are going to go ahead and make your t-chart just like before. If you have a vertical asymptote, center your t-chart on that still. So I'm going to put -2 in the middle and then go left and right from there. If I don't have one, like on number 29, it is absolutely okay to use any points you want. So like I would center it on this hole that I have. So I would put -6 in the middle and then go around there. But use the information that you have to be able to do that. Okay, on 32, You're writing your equation and identifying your asymptotes. Make sure here that you're using, since it says reciprocal parent function, you are using your y equals a over x minus h plus k to fill in all that information. On number 33, it is your rational function, so it's going to look more like number 31 did right here. So this one is more of a challenge problem. Think about, where does your x-intercept come from when you're solving those equations? Where do your vertical asymptotes come from when you're solving those equations? As a friendly reminder, up here, to get your x-intercept anytime, you set your equation equal to 0 and solve. And you guys don't need to do your y-intercepts yet, but you would just plug in 0 and solve. Make sure that for all of your answers, you are checking it on the back, because you do have access to the full answer key in your review. Make sure you finish this all before your test next week.